In this video, I will discuss Fourier's law of heat conduction. Fourier's law of heat conduction is an extremely important law in the study of heat transfer by conduction as well as in the study of heat transfer by convection. Heat always flows unaided in the direction of falling temperature. This is second law of thermodynamics. According to the French physicist Joseph Fourier, the rate of heat conduction through a plane wall in a chosen direction is, number 1, directly proportional to the fall in temperature in that chosen direction. Number 2, directly proportional to the wall surface area normal to the chosen direction. Number 3, indirectly proportional to the distance through which heat has to travel. This distance is the thickness delta x of the wall, whether heat travels in the positive x direction or the negative x direction. This statement is known as Fourier's law of heat conduction. Thus, rate of heat flow in a chosen direction is proportional to fall in temperature in the chosen direction divided by wall thickness multiplied by surface area normal to the chosen direction. This is the basic statement of the Fourier's law in combination with the second law of thermodynamics. Let us now elaborate some terms used in the above paragraph. Fall in temperature in any direction is equal to the temperature at the starting surface minus the temperature at the last surface in that direction. For example, in the figure shown here, fall in temperature is equal to T1 minus T2 in the positive x direction. Difference in temperatures in any direction is equal to the temperature at the last surface minus temperature at the starting surface in that direction. For example, in the figure shown here, difference in temperature is T2 minus T1 in the positive x direction. We use the symbol delta T for difference in temperatures. Difference in temperatures delta T is equal to T2 minus T1. This is equation 2. And this difference in temperatures T2 minus T1 is in the positive x direction. We need to express the fall in temperature in terms of difference in temperature delta T for further use in heat transfer. We can see from equations 1 and 2 that fall in temperature is minus delta T. Thus, Qx, that is heat flow rate in the direction of this arrow, is proportional to T1 minus T2 divided by delta x into A, where Qx is the rate of heat conduction in the direction of the arrow. The symbol alpha means is proportional to. To replace proportionality in the above expression by an equality sign, we introduce constant K, so that this quantity, that is this rate of heat transfer in the direction of the arrow, is equal to Ka T1 minus T2 divided by delta x. Constant K is called the thermal conductivity of the wall material. We assume that the heat flow in the positive x direction is positive. This means that this expression, that is heat flow rate in the direction of positive x direction, is written as positive Qx. Therefore, in symbolic form, we may write Fourier's law as Qx is equal to minus Ka into delta T by delta X. Assume now that the fall in temperature occurs in the negative x direction. Then heat will also flow in the negative x direction. Thus, heat flow will be denoted by this symbol, that is minus Qx, according to our assumption that heat flow is negative when it flows in the negative x direction. The fall in temperature in the negative x direction is T2 minus T1. From starting temperature T2 to final temperature T1, both considered in the negative x direction. Difference in temperature in the negative x direction is final temperature minus starting temperature, both in the negative x direction. That is, delta T is equal to T1 minus T2. Here again we see that fall in temperature in the negative x direction is equal to minus delta T. Thus, Fourier's law for heat flow in the negative x direction is this symbol, which is equal to minus Qx. This equals Ka minus delta T by delta X is equal to minus Ka into delta T by delta X. We note that in the limit when delta X approaches 0, plus Qx is equal to minus Ka delta T by delta X. Actually dt by dx, which replaces delta T by delta X when delta X approaches 0. This becomes the rate of heat crossing plane at X in the positive X direction. Similarly, minus Qx is equal to minus Ka into dt by dx is equal to rate of heat crossing plane at X in the negative X direction. To sum up, we see that rate of heat transfer in the positive X direction is given by this expression, or when we want to find the rate of heat transfer in the positive X direction that crosses a plane at X, then we use symbol plus Qx, that is plus sign is used before Qx to denote this rate of heat transfer. This rate of heat transfer is the same when we consider minus Qx, that is when heat is flowing in the negative x direction. So the right hand side is always the same. The symbol plus or minus goes before Qx if the heat is flowing respectively in the positive x direction and in the negative x direction. Thank you.